Welcome to Study Loop.
In this problem, you are given two lenses and you're asked to solve for the distance between those two lenses for part A and the object location for the microscope. So distance between and DO1. Okay, so we have these two lenses and you have an angular magnification of negative 260. So with the information, I have f2, which is a focal length of the second lens, and I have the distance of the image for the second lens. Now, it does tell us in the problem that this is a virtual image and that it's going to be located to the left of the lens. So I do need to go in and add a little negative here. But with this information, I can use it to solve for DO2. Okay, so this is the distance of the object for the second lens, and that's going to be one of the pieces of information that's going to be helpful for us. So DO2. For that, I can use the thin lens equation. 1 over f equals 1 over DO plus 1 over DI, and I can solve for DO by moving 1 over DI to the other side. And then I have to inverse the entire fraction, not just one little piece of it. Now, because I am talking about the second one, I am going to add little 2's here for clarification. And then this becomes 1 over 4 minus 1 over negative 100. Now, everything is in centimeters, so I don't have to do any conversions. I just do need to make sure that I inverse. So I get a distance of the object of 3.84 centimeters. Okay, so now we're going to use that information to calculate a function for DI1. Okay, and I'll show you what I mean by that. So I'm going to go ahead and just give myself a little bit more space here. And I'm going to use the angular magnification equation, which is DI1 times your near point. I'm going to abbreviate that with NP. There's a little negative here in front. Divided by DO1 times DO2. Again, DO is a distance of the object. So in this case, DI1 is distance of the image for the first. DO1 is distance of the object for the first. And then DO2 is distance of the object for the second. Now, I do have this information and NP. What I don't have is these two pieces. So I'm actually going to solve in terms of variables for this one and then use the thin lens equation to get one of these variables by itself. So let's go ahead and make this, I'm going to bring DO2 up. So times M divided by NP. And let's bring DO1 to the top. Now, this negative is going to cancel out with some of the other negatives that I already have, and then I end up with a function for DI1. Now, I can actually simplify this because I have some of these values. So this is negative 3.84 times negative 260. So already these negatives cancel. And then I have the NP, which is the near point for the eye, which is about 25 centimeters for normal eyeball. And then I'm going to have DO1 as a variable. So that becomes 3.84 times 260 divided by 25. And that gives me a nice, that's convenient, a nice round number of 40. So now we have a function and I have two unknown variables. So right now by itself, it's unsolvable. But I can use the thin lens equation, and I can use 1 over f. Actually, let's start with 1 over DO plus 1 over DI equals 1 over f. And I want to substitute in this equation that I came up with into this function. So this becomes 1 over DO plus 1 over 40 DO. So wherever I see DI, I'm replacing it with 40 DO. And then 1 over F. Common denominator gets me a 40 on this side. And then the top part just becomes 40 plus 1. So I'm going to write 41 up on top, 40 down at the bottom. And then I want to inverse the whole thing. And then I do want to get DO by itself. So I'm going to bring 41 up and then 40 down to the bottom. Okay. So this is 41 times F1, which is the focal length of the first lens. So that was 1. That was convenient. And then divided by 40. So I get a distance of my object of 1.025 centimeters. That tells you where your object is out this way. So this is 1.025 centimeters. And then now that we know what DO1 is, now that I know what DO1 is, I can just multiply that by 40 to find DI1. So this becomes 41. Okay, that means this distance right here is 41 centimeters. But what the problem was asking for was the distance between the two lenses. So I know that this is 41. I know this is 3.84. So altogether, that gives us a distance between, so this becomes DI1 plus DO2 of 44.84 centimeters.